Science, science, science in pajamas. Bum 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 bum. Alright, guys. So welcome back. Today we're doing a demonstration on acids and bases. So first, a little bit of a reminder: acids are compounds that, when added to a solution like or to a solvent like water, but when they're in solution, they tend to break down into one component plus hydrogen ions. So for instance, hydrochloric acid, HCl, would break down into a hydrogen ion, H+, and a chlorine ion, Cl-. So acids, when they are in solution, so when they've been added to a solvent like water and they are in solution, they tend to break down into hydrogen atoms. They do have some very particular characteristics. They tend to be sour. They kind of have a little more of a stinging sensation, as opposed to bases. So we said that acids increase the amount of hydrogen ions. Bases, on the other hand, will not increase. They will actually decrease the amount of hydrogen ions, because when you add a base to a solvent like water, when you put a base into solution, it won't break down into hydrogen ions. It'll actually break down into the component plus hydroxide ions, OH-. So for instance, sodium hydroxide, that's NaOH. When that is added to solution, it breaks down into a sodium ion, Na+, and the hydroxide ion, OH-. So with with acids, hydrogen ions increase. But with bases, the hydroxide ions increase. So some of the characteristics of bases tend to be that they kind of have a foam or a soapy, foamy, kind of filmy type feel. They also tend to be more bitter, not so much the stinging sourness, but more of a bitterness. Now today, we're going to explore some common things around the house. As you can see, it's another field trip to my kitchen, because we're doing demonstrations with things that don't really work as well when you're sitting on a rug in a library. But anyways, today we're going to be looking at a few household common things that you can find, and we're going to be looking to see if they are acids or bases. Now, one way we can do this is with a litmus paper test. Now, there is red litmus paper and blue litmus paper. Sadly, I only have the blue one. But what we're going to notice is that in certain cases, the blue litmus paper should turn more of a reddish color, and in other cases, it'll just kind of look like a darker version of itself. So the substances we're going to be looking at, we have pure water. I'm going to push this down a little bit. So this is pure water. We have soapy water using just tap water. Sorry, this is not pure water, my bad. This is water from the sink, so it's tap water. This is soapy water using Dawn soap, so it's just tap water plus some soap added to it. And we have vinegar, just regular white distilled vinegar. We have lemon juice. I kind of ran out of little containers, as you can see. So just plain lemon juice. And then we have bleach. So just good old-fashioned bleach. All right, so what we're going to do is we're going to add the litmus paper and see what happens. So first we'll start with the water. Not really a change, it just looks wet. All right, so that is the water. Now we're going to try the soapy water. Okay, again, there's the soapy water. And now we're going to try the vinegar. Look at that. We got a color change. Oops, so that's the vinegar. All right, lemon juice. Color change again. And then the bleach. That was a bit of a different reaction than I expected. That one might have been a bad piece. Oh no, you know what it is? Because bleach naturally will take dyes out of stuff. But notice it did not turn red. It did not turn red as opposed to these two. So this is something interesting about litmus paper. It is an indicator paper. In the presence of the hydrogen ions, so in an acid, acids will turn blue litmus paper red. And if you notice, there was really no change with the other items because they were not acids. So this is telling us that the lemon juice and the vinegar are acids. Now, if we had blue litmus paper, we would see something different. We would see that the bleach and the soapy water would have turned red. So, sorry. If we had red litmus paper, the bleach and the soapy water would turn blue. The bleach would probably at some point also take the dye out as well, because like if you've ever spilled bleach on your clothes, you know it kind of messes with the colorations. But even still, you can tell with the bleach one, even though it has that white coloration, it still has a blue band on it. So there's no hint of red at all. So that tells us that bleach is not a base, is not an acid. It is still a base. Now, water wouldn't actually do much of anything, ideally, because pure water is neutral. Now, in terms of the pH scale, it goes from 0 to 14. Now, what is right smack dab in the middle of 0 and 14? 7. So 7 is considered neutral, meaning it doesn't make an excess of hydroxide or hydrogen ions. And that's what pure water is. Now again, we said this was tap water, not pure water, but it's still mostly water. Acids would be the lower end, so 0 to maybe about 6.5 would be considered acidic. About 7.5 or 8, all the way up to 14 would be considered basic. And the further you get away from neutral 7, then the stronger it is. So 7 is neutral. If I go all the way to 0 or 1, then that means that is going to be a very, very, very strong acid. That's where you're going to find things like sulfuric acid or anything like that, the crazy acids you see on TV. Ones that are closer to 7 are your weaker acids. So for instance, coffee is slightly acidic. It has a pH of about 5. Tomato juice is somewhere between 4 and 5. Orange juice, which you guys know we drink, is somewhere between, let's say, about 3.5-ish, give or take. Has a pH of 3.5. Coca-Cola, Sprite, your soda pops, they tend to be around a pH of 3. Vinegar, lemon juice, we'll look at those in a little bit. Milk is actually also surprisingly slightly basic or slightly acidic. It has about 6.5, so it's kind of right on the edge. On the other hand, we said bases are the higher numbers. So blood is slightly basic. It's about, give or take 7.5, somewhere between 7.5 and 8. Eggs are basic. They have a pH of 8. A lot of your cleaners are considered basic. They kind of range depending on what kind of cleaners. Detergent is about at 10. Soap on its own, not including soapy water, but soap on its own is around 11. Ammonia, which is again another strong cleaner, is about 11.5. Bleach, we'll find out. Sodium hydroxide is usually about 13.5. All right, so we have one more test we want to do. We did the blue litmus paper test. We also have pH papers. Now, you can get them where it has the entire range on one, or you can get them where they're more spaced out. So we have pH of 0 to 3 there, pH of 3 to 5.5 here. So those are going to be your more acidic ones. We have 6 to 8, so that's going to be your more neutral. We have 8 to 9.5, that's right there. See, 10 to 12, and 12.5 to 14, those are your more basic ones. So we already know from the litmus paper test what is an acid and what is a base. So I'm actually going to group things now. Lemon juice I'm going to put on one side. The vinegar I'm going to put with it. The soapy water and the bleach I'm going to put together. And the water I'm going to leave in the middle. Because from the litmus paper test, I was able to tell what is an acid and what is a base. Well, now I want to figure out roughly how strong of an acid or a base it is. So that's where the litmus paper test comes in. Or not litmus, sorry, the pH paper. All right, so I have them divided out. I rearranged them. So here is the lemon juice and vinegar. We have water in the middle. Then we have soapy water and bleach at the end. Now I know that the lemon juice and the vinegar are acids. So I'm going to start with those. Instead of using one sheet from every vial, I already narrowed down that it's an acid. So I'm going to take papers out of those so we can look at them. All right. Since I'm not quite sure exactly which kind they are, I'm going to be dipping a piece of paper from each vial into each of them, each of the acids. I'm going to put these right here so you can kind of see those a little bit. All right, so we'll start with the ones that are more neutral or closer to neutral, the weaker acids. All right. Okay, so they're both kind of close to 3, as you can tell. So since 3 is right on the edge, I'm going to test the other one as well. Now, if these turn more of a greenish color, I wouldn't need to test further along because that would be a clear indication that it's somewhere around 4.5 to 5.5. But since they're not, they're more along the lines of 3, which is right at the end, I'm going to come over to the stronger acid paper and see where they might be along that one. Okay, so if we look at these, we can see that they're both somewhere around 2.5 and 2. So they're very close to each other. This one's a little bit more lighter. This was the vinegar. This one was the lemon juice. But they're very, very close. So whichever they are, let's say about 2.5. They're both have a pH somewhere around 2.5. Now the slightly different hues, not enough to really match the 3 or the 2. But we can tell that they're somewhere going to be around the 2.5, give or take. Now, is it going to be exactly? No, one might be 2.2, one might be 2.3, but they're going to be closely around there. Now, if you also notice, the color is faded pretty quickly, so that's why you always want to check it right away and compare it right away. All right, let's get rid of these. And now let's look at the bases. All right, so again, we have our soapy water and our bleach. I'm going to get out some papers to do these tests. So that is 8 to 9.5. I'm just getting my papers out so I have them ready. This is 10 to 12. And then we have 12 to 14. All right. Come on. Here we go. All right. So you can more or less kind of, All right, well, I'll adjust it as needed. So let's go ahead and start. So we have soapy water and bleach. I'm going to put them both in. All right. Now, again, the bleach kind of had a massive effect. It actually flared really dark blue before it went to pale. Again, that's just the nature of bleach. It affects dyes. But if you look really closely, you can see the dark blue band. So that tells me it's going to be at least 9.5. This one doesn't really quite match those. Even though it's lighter, it doesn't even really match that. That's kind of a yellowish green. That's not yellowish green. So I'm going to say, okay, possibly 9.5 for bleach, but still too close to tell. So I'm going to put that up like that. Or roll it to the back. Not quite convinced yet that they fall within that range. So let's grab the next one, which is 10 to 12. Going to dip them in. Alright, so let's see, the soapy water looks like it's about possibly just 10. It's pretty light. This one, a little harder to tell again because of what bleach does, but you can see it has a darker band on the top. Might be about 11. Why don't we just go ahead and double check the last one just to be sure. But right now I'm thinking soapy water might be around 10 possibly, and the bleach could be about 11.5. Let's just see if there's a reaction with the stronger paper. All right, not really much of a reaction. This one just kind of looks wet. That one, again, the bleach took the color out of it, but there's no band at the top that shows a color change. So I'm going to go back to our original thought that the bleach is around maybe 11.5 based on that color band, and the soapy water is close to 10. All right, well now let's take a look at the water. We know that pure water should be neutral. Let's get these out of the way. So now we're just going to take a look at the water. So here we have the paper that is between 6 and 8 with neutral 7 right there in the middle. All right. It's actually a little bit lighter. It's a little bit more on the basic side, maybe even 6.4. Now that's still close enough to neutral. However, the reason why it's not exactly at 7 like we would expect for pure water is because this actually isn't pure water. It's tap water. And that means that there can be minerals or other things dissolved into the water that would affect its pH. So because it's not just plain H2O molecules, there are other things floating in there, it can affect the pH. And actually, if we notice, kind of made it a little more acidic, just slightly acidic. Still close enough to neutral that, well, yeah, it's water, so it's not really going to have a whole lot of acidic properties, but it's still slightly, ever so much slightly more acidic than we would expect. All right, so that concludes our videos on acids and bases. I hope that you guys found it good in terms of an explanation, helping you to understand and grasp these concepts a little bit better. But in the meantime, you guys just stay awesome, stay curious, and most importantly, stay safe and healthy. All right, you guys, take care. Bye-bye.